Good day to one and all present here. I am SITRARASI from Teresa University, and today I will be presenting on disadvantages of using nanomaterials for in-situ remediation. So, a little introduction about the topic. Nanoremediation method entails the application of reactive nanomaterials of 1 to 100 nanometers in size for transformation and detoxification of pollutants. These nanomaterials must normally possess properties that enable both chemical reduction and catalysis to reduce the pollutants of concern. For in-situ nanoremediation, groundwater is not pumped out for treatment above ground, and the soil is not transported to other places for treating it and disposing. For in-situ applications, nanomaterials have highly desired properties. Nanoparticles are able to permeate through very small spaces in the subsurface, and they have the ability to remain suspended in groundwater and achieve wider distribution due to their size and different surface coatings. This allows the particles to travel farther into the ground compared to other larger macro-sized particles. The main disadvantages of using nanomaterials are: it has been proved that nanomaterials used for remediation do not move very far from their point of injection. Many different nanoscale materials such as zeolites, carbon nanotubes and fibers, enzymes, metal oxides and various other noble chemicals, biometallic nanoparticles and titanium dioxide have been explored for remediation. Compared to others, currently the most widely used nanoparticles are nanoscale zero valent ions. Because of the miniature size, nanoscale particles, they move or transport in water by a moment called Brownian moment. It is otherwise called as random motion rather than Wall effects. So, gravity induced sedimentation controls the movement of micrometer scale particles, especially microscale metal particles, because of their size and high density. So, nanoside particles can be easily suspended in water during the design and during their manufacturing stages in the absence of significant surface electrostatic forces, thus providing a versatile remediation tool which allows direct injection as a liquid into the subsurface where contaminants are normally present. So, iron nanoparticles are commonly coated to improve their catalytic reaction rates and mobility. Most nanoparticles are filtered out and they bind to soil particles, but some of the particles actually flow with the groundwater and they remain in suspension for various amounts of time. This provides an in-situ treatment zone that could hold back other emanating plumes. So, when artificially synthesized nanomaterials are released into the environment, to some degree they aggregate together and they act like natural nanomaterials. These colloids could form highly mobile, stable nanoclusters in groundwater that are likely to be carrying surface sorbed contaminants with them. So, these particles can carry materials in between redox zones and thus they facilitate or inhibit contaminant transport. The mobility of synthetic or natural nanoparticles in the natural environment strongly depends on whether the nanoparticles remain aggregate and settle or whether they get completely dispersed and form mobile nanoclusters. Gilbert et al. In 2007 suggested that many manufactured inorganic nanoparticles, including metal oxides, will be similar to that of natural nanoparticles and they exhibit cluster forming behavior. The fundamental transport and aggregation properties of nanoparticles have not been extensively studied, despite numerous observations that conclude that the nanoscale minerals represent an important fraction of the environmental colloids. Other than self-aggregation, nanoparticles could also associate with other sediments and suspended solids, where they could enter into the food chain of drinking water sources through bioaccumulation. The fate process of the nanomaterials depend on both the characteristics of the environment system and the characteristics of the particles. So, in conclusion, most societal issues are based on the unknown risks that come with using nanoscale materials for in-situ remediation. Many non-governmental and non-profit groups have actually invoked the precautionary principle to halt or stop the use of all the technology that uses nanomaterials unless and otherwise it is proven completely safe. These are a few references used for this presentation. Thank you.